Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this second video lecture of 8 week, today we are going to discuss some problems for practice regarding solution of system of linear equations by LU decomposition method. Dear students, we have already discussed this topic, solution of system of linear equations by LU decomposition method, but here I would like to discuss some problems for practice related to solution of system of linear equations by LU decomposition method. So as I have already told you that LU decomposition of a square matrix is always possible to factorize a square matrix into a lower triangular matrix and an upper triangular matrix, which is called decomposition of a square matrix. For the decomposition of a square matrix or solution of system of linear equation by LU decomposition methods, the procedure steps are as: first of all, create matrices from AX is equal to B of the system. First of all, write the system of equation in matrix form, where A is the coefficient matrix, X constitutes the variable matrix, and B are the constant. And second step, suppose let A is equal to LU, where L is the lower triangular matrix and U is the upper triangular matrix. Assume that the diagonal entries L is equal to 1, and you can assume the diagonal entries of U is equal to 1. And in the third step, when we find L and U in the second step, then use the lower triangular matrix L and the matrix B for finding the column matrix Y. So use Ly is equal to B to solve this equation for Y. To find a column matrix Y, use Ly is equal to B, and then use the matrix U and the matrix Y for the solution of system of linear equation. So use Ux is equal to Y, solve for the variable matrix X. X contain the unknown entries of the system of linear equation. Now, dear students, as I have already told you that LU decomposition of a non-singular matrix, when it possible, is not unique. In practice, we use one of the following alternative to get unique factorization. We can use Kraut formalism. In Kraut's method, all the diagonal elements of U is chosen 1. And do letter formalism, all the diagonal elements of L is chosen 1. If we choose the diagonal elements of the upper triangular 1, then the method called Kraut's decomposition. And if we choose the diagonal element of the lower triangular L1, then the decomposition called the Doolittle decomposition method. Now suppose we have a system of linear equation, and after writing the system of linear equation, we obtain the matrix A 1 2 3, and in the second row 3 4 11, and in the third row 5 14 and 12, and the matrix X contain the unknown variables X, Y, and Z, and in the system of right hand side we obtain the constant 5 21 and 15. So the matrix B is 5 21 and 15. Now to solve this system for this matrix X by LU decomposition, first of all determine a lower triangular matrix L and an upper triangular matrix U such that A is equal to LU. Use this above factorization to solve the equation AX is equal to B. Now first of all, decompose this matrix A into L and U. So A is equal to LU. This is the lower triangular matrix A00, BD0, CEF, and the upper triangular matrix contain in the first row 1LM, 01N and 001. So in the lower triangular matrix, if in the lower triangular matrix the diagonal elements is chosen 1, then the method of decomposition called Doolittle decomposition method. So this is actually a lower triangular matrix and this is actually upper triangular matrix. So since here I assume the diagonal elements of the upper triangular matrix is 1 1, so this is called Crookes decomposition method. Now multiplying these two matrices, we obtain A is equal to A, AL, AM, and in the second row B, BL plus D, BM plus DN, C, CL plus E, CM plus EN plus F. Now equating the corresponding elements of the two matrices we have. Dear students, when we multiplied the lower and upper triangular matrix, we obtain a single matrix, and this single matrix actually equal to the matrix A. So by comparison, we obtain A is equal to 1, B is equal to 3, C is equal to 5, AL is equal to 2. Now AL is equal to 2, put the value of A is 1, so the value of A is 1, so L is equal to 2 by A, but the value of A is 1, so L is equal to 2 by 1 is equal to 2. Now AM is equal to 3 and the value of A is 1, so M is equal to 3. Now BL plus D is equal to 4, so we can write D is equal to 4 minus BL. The value of B is 3 and the value of L is 2, so D is equal to 4 minus 3 into 2 is equal to minus 2. Now CL plus E is equal to 14, and we can write E is equal to 14 minus CL. The value of C is 5 and the value of L is 2, so E is equal to 14 minus 5 into 2, 2 5 the 10, 14 minus 10 is equal to 4. Now BM plus DN is equal to 11, and this implies that N is equal to minus 1 over 2, mean N is equal to 1 over D. This is actually the value of D, but 11 minus BM, 11 minus BM divided by D. So N is equal to 1 over minus 2 into 11 minus 3 into 3, and this is actually minus 1. Now CM plus EN plus F is equal to 12, and we can write for finding the F is equal to 12 minus CM minus EN. Putting the value of CM, E and N, we obtain 12 minus 5 into 3 minus 4 into minus 1 is equal to 1. Now we obtain the lower triangular matrix 1 0 0, 3 minus 2 0, 4 5 4 1, and the upper triangular matrix is 1 2 3 0 1 minus 1 0 0 1. Now in the second step, now since we have the lower triangular matrix and the upper triangular matrix, we can write AX is equal to LU, replace A by LU, so AX is equal to LU into X, and we can write this is equal to LY and LY is equal to B. Actually UX is equal to Y, UX is equal to Y, so LY is equal to B. Now to find the column matrix Y using UX is equal to Y and Y is equal to Y1, Y2, Y3. This is the column matrix. For the Y matrix, This is in this expressions there are two unknown. X is unknown, y is also unknown. So first of all, find the y matrix. For the y matrix, use this expression Ly is equal to b. So this is the lower triangular matrix. You see over here, this is the lower triangular matrix, and this is the y column matrix, and this is the matrix B. Now by multiplying and by using the forward substitutions, we obtained y1 is equal to 5, y2 is equal to -3, and y3 is equal to 2. Now using this y matrix and using this relation ux is equal to y, putting the value of y matrix and the value of upper triangular matrix, we can find the unknown matrix X. As you see over here, ux is equal to y. This is the upper triangular matrix, this is the unknown matrix, and this is y, y1, y2, and y3. Now using the backward substitution, here actually the z value as 2. Now the y minus z, y minus z is equal to -3. Putting the value of z, we can find the value of y, which is -1. And in the first equation, x plus 2y plus 3z is equal to 5. So putting the value of y and z by using backward elimination, we obtained the value of x is 1. So the unknown matrix is equal to 1, -1, and 2. This is the value of x, this is the value of y, and this is the value of z. So dear students, when we solve a system of linear equation by LU decomposition method, you can decompose the coefficient matrix A by using the Kraut decomposition method or Doolittle decomposition method, and I have already told you in the previous video lecture. So if we choose the Kraut decomposition method, this is simple, mean that the diagonal element of the upper triangular matrix will be 1 1 1. So this is actually Kraut's decomposition, because this is the upper triangular matrix and the diagonal elements of the upper triangular matrix is chosen 1 1. And if we use Doolittle decomposition method, means if the diagonal elements of the lower triangular matrix is chosen 1 1 1, then these three entries will be unknown, and these three entries also will be unknown. But the first matrix, if we use the diagonal elements of the lower triangular matrix is 1 1 1, then the first row of the upper triangular matrix will be same as like the first row of matrix A. And if we use the Kraut's decomposition, mean if we choose the diagonal elements 1 1 of the upper triangular matrix, then the first column of the lower triangular matrix will be as like the first column of the matrix A, and the other entries in L and U will be unknown. And we can find easily the unknown by multiplying these two matrices, and then by comparison the matrices we can find the unknown. Actually there are 9 unknowns, 1 2 3 4 5 6 and 7 8 9. So by multiplying these two matrices, we obtain a single matrix, a single square matrix like this matrix A. So by comparison the corresponding elements we can find the unknown, and after that we can find the lower triangular matrix and upper triangular matrix like you see here. And when we find the lower and upper triangular matrix, then find the y matrix using matrix L and matrix B. And when we obtain the y matrix, then using this relation ux is equal to y, putting the value of upper triangular matrix and y matrix, we can find the x matrix. And dear students, note that when we use this relation Ly is equal to b for y, you can use the forward elimination, and when we choose this relation at the end for the x matrix, we can use the backward substitution method. Easily you can find the unknown matrix X. And now this is the end of this segment. Thank you. Allah Hafiz.